Very good evening, students. This is Dr. Srinivas, Master Academy of Mathematics. So once again we are welcoming to our mathematics channel. So today we are going to discuss about the main important points in unit number 4 of Calculus, Mathematics 1, R18 and R20 regulations of JNTUH Hyderabad. When you look onto the syllabus of calculus part, the main points here it is the total calculus part based on the principles we call it as mean value theorems, which is divided into two types: generalized mean value theorems and centralized mean value theorems. And again generalized divided into Rolle's, Lagrange and Cauchy, whereas centralized Taylor's and Maclaurin's series. After that, gamma function and beta function, special type of integrals. Then you entered into surface area and volume of the solids. When you look on to the important points here, the first one, verify Rolle's mean value theorem for a function in an interval. Here it is given. Verification in the sense you are just checking the properties of Rolle's mean value theorem, and if all the properties are satisfied, indirectly you are calculating the C belonging to the open interval satisfying a condition f dash of C equal to 0. Second, you are verifying Cauchy mean value theorem for f of x equal to root x and g of x equal to 1 divided by root x in the standard interval a comma b. So very easiest thing, you can check your properties of Cauchy mean value theorem for the two functions and you are calculating the C value indirectly. Third one, expand logarithm of 1 plus e power x. Since there is no point at all, directly you can use Maclaurin's series for this. Fourth one, evaluate integral 0 to infinity e power x cube into x power 7 dx and integral 0 to infinity e power minus x square x power 4 dx. Almost both are similar. Limits integral here it is 0 to infinity is given. So better you are converting into gamma function by supposing in the first integral x cube equal to t and in the second one x square equal to t. Just on replacing with a new variable and directly it can be converted into gamma function. Fifth one, prove that gamma of equal to root by it's a direct problem. With the help of your polar coordinates of beta function, you can directly find out its proof. Sixth one, prove that integral 0 to pi by 2 sine power m of theta cos power n of theta d theta equal to that value. So directly you just compare with your polar coordinates of beta function and you can find out directly its value. Seventh one, find integral 0 to pi by 2 sine power 7 of theta. Since there is no cos term, so only sine power is there, that 2m minus 1 equal to 7 and 2n minus 1 equal to 0. Just on comparing with your polar coordinates of your beta function, you can find out its integral value. Eighth one, integral 0 to 1 x square by under root of 1 minus x power 5 of dx in terms of beta function. Normally integral 0 to 1 is there, so it is a beta function of first kind. The general notation is x power m minus 1 into 1 minus x whole power n minus 1. That is the general principle for beta function. So here the difficulty is there. X power m minus 1 you can directly calculate, but 1 minus x to the power of 1 minus x whole power n minus 1 is there, that is not there. So in order to get that value, you start with that x to the power of 5, it is equal to some t, and on making the simplification you will get the answer. Ninth one, evaluate integral 0 to 1 x cube into 1 minus x under root of dx. So just you can use your beta function definition, and after getting the beta function you can convert into gamma function by using a relation for both the integrals. 10th problem, expand tan inverse of x in the powers of x minus 1. So since the point is given, indirectly you are using Taylor series. Here the point A is taken as 1 and B equal to x. You can directly substitute in Taylor series formula. Expand sine inverse of x. No point is given, you can use Maclaurin series. Even 12th problem also, expand e power sine inverse of x. Whenever you are calculating the different derivatives of e power, very simple, you write down e power as it is into derivative of that power. So just you calculate your expansion. 13th, prove that tan of x by x greater than x by sin x. Here the limits 0 to pi by 2. Remember, in order to prove this type of statement, we are going to consider two different functions. One is f of x equal to tan x. By that, you can calculate tan x by applying your Lagrange mean value theorem. Similarly, on the other hand, you take another function, some f of x, which is nothing but sin x of the right hand side. Again, on applying the Lagrange mean value theorem, you will get one expression. You just compare these two expressions, you will get your required answer. Prove that pi by 6 plus 1 divided by 5 root 3 less than sin inverse of 3 by 5 less than pi by 6 plus 1 by 8. So here directly you can use Lagrange mean value theorem for this. Here the interval is taken as a comma b, and finally on applying Lagrange mean value theorem, you can get b equal to 3 by 5 and a equal to 1 by 2. So by that you can get your final answer. 15th problem. So prove that a statement is given. Here also you are using same Lagrange mean value theorem. Whenever such type of statement is given, maximum you are going to use only Lagrange mean value theorem. When nothing is mentioned, you start with the standard interval a comma b, and finally after getting the final statement, you decide the values of a and b. 16th, find the surface area of the solid generated by, only a function is given, and for that function about x-axis we have a standard formula. Directly you can find out the answer. Find the volume of the solid enclosed by xy equal to 1 and x equal to 1 about x-axis. So we have here it is two different functions here it is given, and corresponding to that function you are calculating the value. Prove that modulus of cos b minus cos a less than or equal to modulus of b minus a. Normally you can use your Lagrange principles in order to get your statement. 19th, integral 0 to infinity x power m minus 1 a minus x whole power n minus 1 of dx. Very simple. In order to get beta function, x to the power of m minus 1 is there, and instead of 1 minus x, here it is a minus x is there. So you take a common and just you make the simplification, you will get the answer. 28th problem. Prove that integral 0 to infinity x power a by a power x dx equal to some gamma function is given. So here also the typical variety term in the integral is nothing but a power x. Start with a power x equal to some t, and just you do the simplification, you will get the answer. So these are the few important problems in your unit number 4. A very simple thing is, only you need to understand the basic concept of calculus part. By that you can easily find out the different solutions of the given problems. So once again we will look onto the complete problems here, or else I start with your first problem. So belonging to unit number 4. The practice is very important in order to do the problems. You need to have an idea on each and every topic so that you can easily find out your respective problems. Okay. So in the next video session, I give you its key, that means the solutions of this particular unit number 4, so that it is very much useful even in the examination point of view. Okay. Thank you.